Okay, hello everyone and welcome to another Motec webinar. My name is Mark McCoy and I'll be your host for this subject. Today we will be doing a continuation or a part 2 of how to set up cam control. Today's topic is pretty much based on the actual auxiliary output. Cam control part 1 was about the input to measure the cam position. This is about the output to make the cam actually do stuff. So there will most probably be a part 3 to this webinar. We're trying to keep the subjects fairly short to not bore everyone too much. So this is basically some of the tests and bits and pieces you need to do to get the cams actually moving. You should have the cam digital input set up before this anyway, just to make sure that you have everything working. Okay. The topics for today will be the auxiliary output, the frequency, auxiliary table test, and the polarity, output mode, high-low limits, normal position, and also some advice on bank-to-bank differences, and that's mainly to do with V engines or boxer engines. Firstly, we'll be talking about the auxiliary output. Now, the auxiliary output function is number 117. There is another output for some of the earlier BMW engines that actually use 2 injectors to move the cams backwards and forwards. Not specifically going to talk about those engines in this series of webinars because they're fairly uncommon and we have some pretty good start files for those, although this webinar is still probably worth watching for these. So you can run the auxiliary outputs for cam control on any of the auxiliary outputs, 1 to 8, it doesn't really matter. You can also, if you've got an M800 or M880, you can run them on any spare injector or ignition outputs. So the function is number 117. That's what we're talking about today. First thing you want to decide is a frequency. This function is a pulse width modulated function. So basically that means we vary the duty cycle of the signal and it's at a fixed frequency. What I would normally do is get an oscilloscope and hopefully you've got a running car at some point. So some of this testing should be done before you start cutting up wires and installing the Motec. But what I would do is if I had access to a running engine, I would simply use my oscilloscope to measure the frequency of the cam control output, as set up by the factory with their ECU, just to give me an indication of basically what frequency I'll be looking at. This could be anything from 120 up to 300 Hertz. So that the signal is fairly fast frequency, and that frequency can be adjusted. Sometimes on the dyno, if I notice I'm not quite getting the response I want, I will change around the frequency. This needs a bit of experience, so it's not something that everyone's going to be doing, but having an idea of where the frequency needs to be to start with is always a good thing. What we also want to do is we basically want to characterize the movement of the camshaft. Now the easiest way to do this is, instead of using the full cam control function, which is a closed loop function, we're going to more or less set up the cam control as an open loop system. Now by that I sort of mean that there's going to be, the ECU isn't going to be trying to control to a position. We are actually going to be feeding our own duty cycle to the cam to make it move around. Now this is not how it'll run in the normal car, this is just purely for the test. So instead of putting in function 117, you want to put in function 3, which is auxiliary table. So what we're going to do is, and I've got the parameters just down here that you can sort of see, we want to make the pulse width modulated output, so if you leave it as 0, it'll be pulse width modulated. We have the output mode. This is whether it's a high side drive or a low side drive camshaft system. I'll get into this a bit later. Polarity also, I'll mention that a bit later, but polarity for the moment should stay as 0. The output mode will, again, like I said, depend on how this thing's actually wired. We'll put in the frequency, hopefully that we've learned from the factory car. We'll have a minimum duty cycle of 0, a maximum of 100, and the hysteresis, you don't need to worry about that. We're not using that for this function. Another thing you want to do is you want to go into your table, and to make things nice and easy, if we press A for axis setup, we want to turn off both axes, and that's a simple matter of just getting rid of the little tick in the circle there, and that will mean our table is just simply one number. So we're not having to chase the engine based on RPM or throttle position or anything like that. We're going to do this test as what we call a single entry table, so literally just one number. So no matter what the engine's doing, that number or that duty cycle will be applied to that camshaft. A couple of things you also want to do, like I've mentioned in other webinars, you want to have a screen in your 100 series software, or even in your 100 series software. I would usually have a chart recorder for the duty cycle of the cam I'm looking at, in this case auxiliary output 1, and also the cam position of the actual cam I'm looking at. So in this example, we're looking at the cam position inlet, and it's on auxiliary output 1. Now what we're going to do is basically start with our table, and we're going to start at 0, and we're just going to use the page up button to go up in duty cycle. So you can see here in my section that I've labeled A that we're starting at 0 and we're slowly moving the duty cycle up. Now from our actual cam position, you can see down here in the A area that we're not actually moving the cam. So that means we haven't quite got to the duty cycle that's going to make this cam move. But then if we move to section B, you can see I've hit a certain amount of duty cycle, and look at that, the cam's raced away and gone all the way up. So in that cam position B, I've sort of set a limit of about 30, and what I'm sort of getting at here is that's like a mechanical limit. So here I didn't have enough duty cycle to move the cam, so it's going to be sitting against its fully retarded mechanical stop. I've gone up in the duty cycle, and suddenly I've got to a point where a duty cycle that makes the cam move, and bang, it's gone hard against the fully advanced mechanical stop. You should be able to hear this in the engine's note. So you're moving the camshaft at idle, you're going to be able to hear it in the note of the engine. So you might have to be a bit careful, because it might be a little bit too much advanced and it might stall the engine. So maybe you want to do this with a bit of throttle. So that's no good. It's fully against a stop. What we're actually looking for in C is we bring down the duty cycle and the cam starts to move backwards, as you'd expect. So right as we go between C and D, what I'm doing is I'm going page up, page down, page up, page down. So I'm varying the duty cycle around, in this example, about 35, and I can see that the cam position has maintained a nice steady position of 16 in this case. I want to find what duty cycle will allow me to have the cam holding in one position. I don't want it against the fully advanced mechanical stop, and I don't want it against the fully retarded mechanical stop. In reality, if you go down a couple of percent duty cycle, the cam will start to move down very fast. If you go up a couple of percent, it will move forward very fast. So you might have to sit there, page up, page down, page up, page down, and just find any position. It doesn't have to be 16, it can be 5, 10, 20, something like that. But I just want to know what duty cycle will hold the cam in a position. So in my example here, I've got 35. Now for a late model Subaru, that could be 80. For a Ford V8, that could be 50. This is the test that we use to find what that duty cycle is. Most importantly, not against the fully advanced mechanical stop, not against the fully retarded mechanical stop, somewhere in between. The other thing you have to check while you are doing this test is which direction does the cam move in. Like, does the cam position go up in numbers, so I go from 0 to positive 30, or do I go from 0 to minus 30? Generally what happens is a inlet cam will move forward, so it will advance, and an exhaust cam will retard. So this sets what polarity we need. This is very important. If you get the polarity wrong, the ECU is going to be trying to calculate numbers and driving the cam shaft in the wrong direction, and it simply won't go. So, as a rough rule of thumb, if the position increases, goes up, the polarity needs to be 0. If the position goes down, the polarity needs to be 1. So generally speaking, inlets are 0 and exhausts are 1. I haven't really found an engine that does anything different to that, so there's a bit of a clue there. Now the output mode thing, probably should have had this a bit earlier in the seminar, but you'll get the idea. The output mode depends on how the system is actually wired. In the old days, pretty much everything was what we call low side drive, where the device, let's say that's the cam position solenoid, was wired to 12 volts permanently. So you turn the car on, the solenoid gets 12 volts. The ECU provides the ground path. Okay, so it's a switch to ground, or a low side drive. So in the polarity and output mode settings in the auxiliary output, once you have it set up as 117, there will be a parameter which is polarity and output mode. So one of them sets the direction, as we were talking about on the previous slide, and the other one sets how the thing is wired. So it's sort of one number does a couple of different jobs. So if it's low side drive, you'll have 12 volts connected, and the ECU will be providing the ground path. Now, if it's connected to chassis earth permanently, then the ECU needs to supply the 12 volts, and we call this a high side drive. Anyone who's been working with K20A Hondas for a while will know that about 3 or 4 years ago, Honda decided to change the way they wired these systems, and they went from a low side drive to a high side drive. So we made a bit of a change in the software to allow, high side drive for cam control, which means you don't have to rewire the car anymore. Part of the reason why you buy a Motec and not anything else, I suppose. But those settings, if you have a look in the parameters for function 117, you'll see that 2 or 3 are the directions if you have a high side drive system. Okay, if that's a little confusing, you might want to watch this a couple of times or send me an email, but there's the basic explanation. The high and low limits. Now this is a couple more parameters in your function 117. These are very important. Effectively what we need to do, by our little auxiliary output test before, we found that 35% duty cycle holds the cam in a specific position. Okay, higher duty cycle, the cam goes forward. Lower duty cycle, the cam goes backwards. The way we tell the ECU that we want 35 as a holding duty cycle is we have to set like a high and low limit. Now, halfway between that high and low limit is where the ECU assumes is the holding duty cycle. It's a bit of a roundabout way of doing it, but that's why we're doing the webinar, I suppose. So, if we had 35 as the holding duty cycle, my high limit is going to be 35 plus 5, so 40. My low limit is going to be 35 minus 5, and that's 30. So they're the two numbers you would enter. The ECU will calculate halfway between, fairly simple maths, and work out that 35% duty cycle is a holding duty cycle. Now these are an integration limit, this +5 and -5. So effectively it puts a clamp on how far the integral part of the PID, remember this is a closed loop system, how far the integral part of the system can drive the cam. Now it's very important to get these right, because if you have, let's say our holding duty cycle was 35 and I set a high limit of 80 and a low limit of 70, the ECU is going to assume that the holding duty cycle is 75, remember halfway between, and what you will find is the cam simply will not go where you want it to. It'll try, it'll sort of look like it's moving, but it just will never get to your aim position and the control won't be real great. Like, I've seen this a number of times. So you have to do that test first off. If I turn up to the dyno with a new engine or one that I haven't been involved with the setup, the first thing I'll check, I mean it only takes about 5 or 10 minutes, is go in and do that auxiliary output test just to make sure that what is set up in the high-low limits is correct, because if the high-low limits is incorrect, the thing won't work properly. We've had a number of engines over the years that you'll get one model, like maybe a 2008, and it will have a holding duty cycle of 35. You get next year's model, throw that same file in, suddenly the cams don't work, you do your test and you find that the holding duty cycle is now 80. Subaru did that to us once, so that's why we have to sort of be a bit on top of it. And if it's an engine, especially an import engine where you don't really know the origins, these are the tests you have to do. They don't take very long and it'll save you a lot of phone calls and a lot of headaches. Just a bit of a special note down the bottom there, for cams needing a polarity of 1, if we've done the test using the auxiliary output table, as I did before, we sort of need to mess the numbers around a bit. The polarity more or less changes the direction of the calculation. Now if we've got this number 35 from a different function that's not running backwards, so to speak, for this polarity of 1, the holding duty cycle would be 100 minus the testing holding duty cycle. And that's only if you've got a polarity of 1, so generally exhaust cams, like I said. So you have to change the numbers around. It's a bit of a reverse thing. I'm not going to go into explaining the software behind it, just trust me. If you've got a polarity of 1 and you've done a testing duty cycle of 35, that holding duty cycle for a polarity of 1 is actually 65. So high limit, low limit is 65 plus or minus 5. When I do my next webinar, I'll sort of explain. You can see I've said the holding duty cycle, plus or minus 5 is a starting point. Once you get into the tuning of the PID system, you may want to change these around. Generally speaking, as a rough rule of thumb, plus or minus 5, I think in my experience has been pretty good. But this all depends on the accuracy of how you came up with that holding duty cycle. So you need to do that test to make sure everything's working properly, because trust me, if you get it wrong, it won't work properly. Normal position table. The normal position table, we've kind of got two different ways of approaching this function. If we test for a holding duty cycle, and then we do the high-low limits, as I was saying before, that only gives us one holding duty cycle for the entire operating range of the engine. Now, for anyone that knows PID, that holding duty cycle is effectively a feed forward. If you have a look at my PID webinars, you'll get an explanation of what that is. Some engines obviously can change from being cold, first cold start of the winter, to being hot, driving around the track in summer. So what you can do is, if you know that the normal position or the holding duty cycle changes with something, generally it would be oil temperature, because oil is what runs the system most of the time anyway, you can actually do some tests. So you find the holding duty cycle when it's cold, the holding duty cycle as it's warming up, and the holding duty cycle when it's hot, and then you can actually build a table. It's under adjust functions cam control. There's a section there. So you can actually put in a table of holding duty cycles. The only one thing to remember there is if you set it up that way with the table, the high and low limits become more or less absolute. So your high and low limits in the auxiliary output would now be +5 and -5, not holding duty cycle plus, holding duty cycle minus. So they go to the absolute integral limits then, because this table here is in a separate section of the software. So two different ways of doing it. I would suggest that if you are starting off doing this and just getting your head around it, so to speak, I wouldn't worry about the normal position table. Just leave it all as 0 and then simply set your high-low limits as holding duty cycle plus, holding duty cycle minus. And then if you notice that your cam control is not very good when the engine's cold, then you would do something about it. I sort of suggest to people that you want to start out fairly simple and then add the complications once you've sort of mastered the basics. Don't try to set it all up at once for the start if you've never done it before, because it will just get confusing. Bank to bank. Now, if you have a V engine or a boxer engine, never assume that the left bank and the right bank need the same settings. I've been caught by this before. A very good example is the Nissan VQ35 series of engines. If you do the early model 350Z engine, you can generally set up the inlet on the left and the inlet on the right banks with the same parameters, the same high and low limits, and they will both work. But I did an import engine a while ago, and I found that I just naturally assumed it was a 350Z, so I threw the same high-low limits into both banks, and then the right-hand bank simply would not work. So I went back and did my tests on each individual cam, and I found that the right bank had different numbers to the left bank by a fair margin. So once I had my testing done and I had my holding duty cycle, I could set up the left inlet and the right inlet different, and then they both work perfectly. So individual tests should be done on every cam. Never assume the same setup between left and right banks on V or boxer engines. Sometimes they are, sometimes they aren't. Again, get a lot of people going to the import wreckers and buying a whatever engine without really knowing the origins. So we haven't tested every single one of them. So I reckon about 5 to 10 minutes of messing around with making a coffee in between, and you've got all your information. So if you do the test to start with, even if you have problems and you need to ring me, you've at least got the numbers to back that up, or preferably some data logging. Okay, thanks everyone for joining me for this webinar. As with all our webinars, they are recorded and they will be put onto motec.com.au under our webinars section. Also, if you're not already a member, probably a good idea to join our Motec forum. So if you've got any after hours questions, they can usually be answered by knowledgeable dealers and customers around the world. So again, thank you for joining, and I hope you can attend the next one. Thank you.